In problem 2, we're going to test whether or not an increase occurred in the mean hourly earnings. In 2001, the mean hourly earnings for U.S. workers was $14.32. To determine whether mean hourly earnings went up between 2001 and 2003, we have taken a sample of 51 production workers during the year 2003. The mean of this sample was 1486. We're going to assume the population standard deviation is $2. And then again, we want to know if there was an increase in the mean hourly wage from 2001 to 2003. Since the null hypothesis always includes equals, and the statement that is highlighted in gray says increase rather than the same or an increase, the statement highlighted in gray is the alternative hypothesis. Mu in the alternative hypothesis is the 2003 average, which we cannot know, which is why we took a random sample of 51 workers and asked each of them how much they were making per hour. The 1432 is the annual earnings average of production workers in 2001. Since the null hypothesis is the opposite of the alternative hypothesis, the null hypothesis must be less than or equal to 1432. The point estimate of the population mean for 2003 is the sample mean that was computed in 2003. In this case, 1486. So 1486 is the estimate of the hourly wage in 2003. The difference between 1486 and 1432 is the point estimate of the difference between the population mean and its hypothesized value. The sample mean, assumed population standard deviation, sample size, significance level have all been copied into Excel. Down here, we computed the difference between the point estimate of the population mean for 2003 and its hypothesized value, which is 0.54. The variance of the variable is the square of the population standard deviation. The variance of the sample mean is smaller than the variance of the variable, because the variance of the sample mean is the variance of the variable divided by the sample size. The standard deviation of the sample mean, also known as the standard error of the mean, it is equal to the square root of the variance of the sample mean. The test statistic is the ratio of the point estimate and the difference and the standard error of the sample mean. So the test statistic is 1.92819. The alternative hypothesis indicates that this is an upper tail test because it says mu greater than 14.32. So we're going to divide the alpha level, 0.05, by 1 and not 2. So the alpha divided by 1 level is 0.050. Now, because we want 3-digit decimal accuracy of the critical value, we're going to go to the infinity row and column 0.050 of the t-table. If we get the critical value from the standard normal table, we only get 2 decimal accuracy. In column 0.05 of the t-table, we scroll down until we get to the infinity row, and the z-value is 1.645. So our critical value, because it's an upper tail test, is going to be a positive 1.645. Now we're going to enter this information into Cengage Now. So the first thing we're going to just copy this 1.645 into Cengage Now down here. The critical value is positive because it's an upper tail test, mu greater than 14.32. The standard error and the test statistic have to be to 4 decimal places. So I'm going to paste in the standard error and the test statistic of 1.9282. Since the test statistic is greater than the critical value, we're going to conclude that the 2003 average hourly wage is greater than what it was in 2001. Thus, we're accepting the alternative hypothesis and rejecting the null hypothesis. Thus, we can conclude that there has been an increase in the mean hourly wage of production workers. After I hit check my work, notice that I have all the green check marks. So what does this test imply? The test implies that from 2001 to 2003, average hourly wages went up.